This is part 4 of the introductory C# programming series for novice programmers. Today we're going to be talking about looping. Loops are everywhere in computer science. They are used when you need to repeat the same section of code over and over again, and are often used to work your way through a list of something, or repeatedly ask for input, or wait for a network packet to come in, or process through any sort of bulk material. So loops are everywhere, and they come in a variety of types. And in C#, there's probably 4 major loop types. Uh, and depending on what you are attempting to accomplish will determine which type of loop you're going to use. Uh, the 4 types are the for loop. This is generally used when you know exactly how many times you want to loop. Oftentimes used when you iterate through a list of something like an array or or such, where you know the number of items you need to process at the beginning of the loop. A for loop there is structured such that it easily moves through a known number of items. The while loop is generally used when you don't know exactly the number of times you're going to loop and you're going to end on some type of condition. And in a while loop, it tests the condition as to whether it should loop or not at the beginning, which means that it may not loop at all. It may skip your loop code entirely because it tests for the condition to be true before looping. A do while loop is exactly the opposite of a while loop in that it tests the condition for continuation at the end, which means it will always execute your code one time and then check to see whether it should repeat. So those two really kind of work similarly in that they are not fixed with a number of times of iterations. Generally, they're reactive to conditions. And the last one is a foreach loop. This is used when you want to process through a list of iterable items that where each item in the list is of a certain type. So, for example, if I had a list of strings, I could loop through there for each string in this list, and it's a sort of a slightly shorthand way of what would traditionally have been done with a for loop. So the first one that we're going to look at is the for loop. The syntax for a for loop is the reserved word for, a parenthesis, and then a set of values that determine the initial index value. This is the item that is counting in the loop. Then we have a continuation condition. This is a test. This is a conditional statement that tests whether or not the loop should continue. And then the third item is the increment value to the index that we're counting on and testing. So this could go up by 1, it could go up by 10, it could go down by 1. The increment could go any direction you want. So the loops don't necessarily have to count by ones, and they don't necessarily have to count upward. They can count downward. This is entirely in your control in this index increment section. And then within the curly braces, as with everywhere else in C#, you can put a block of statements inside of the for loop. That includes nesting additional loops. When you're doing sorting algorithms, a lot of times you'll do nested loops where you'll loop through the items a certain number of times, and then within each loop you'll be looping through items as well. So here's an example of a for loop if formatted. The reserved word for, and then the opening parenthesis, and then I declare an integer named I, and I set its initial value equal to 0. This is one of the most common uses of a for loop, is to index a 0 indexed array or list or something. Then the semicolon, and then this is going to continue while I is less than 30. So as long as that condition is true, the for loop will continue to loop. And then my increment statement is I++. Now, that's a fancy way of saying increment I by 1. That's called a postfix operator, and it's kind of a neat way of doing it. And then inside my statement block of my parentheses, I have the statement that's going to execute each time through the loop. In this case, it's going to write out to the console the value of I. So on the screen, I should see basically 0, 1, 2, 3, 4, 5, all the way up until I is no longer less than 30. So I should see it go through 29. So let's go look at a couple examples of for loops, and we'll see this in action. Okay, let's do a for loop here. So I'm going to do the one that I just did, for, and then int I equals 0, I less than 30, I plus plus, whoops, curly braces. I can now do as much code here as I want. I'll just do a console dot writeline, and I will write out the value of I. That's the end of the stuff I want to do inside my loop. So I'll come out here and say console dot read line. That's to pause my program and execute. And there's my numbers 1 through 29. Let's make a few changes here to the console so we can see it a little bit better. Let's make it old school and make it look like a terminal. Maybe bump that font size up a little bit. There we go. And 0 through 29. Okay, let's see what else we can do with our for loop. Let's say that over here in my increment statement, instead of I++, which is that go up by 1 operator, I can put any statement in here. So I can say I is equal to I plus 3. So this will take the current value of I, which the very first time through the loop is 0, and it'll add 3 to it. And if I run this one, you'll see that I get 0, 3, 6, 9, etc. So it's incrementing up to and stopping when this condition is no longer true. I can also adjust my value of I in here. So I could say I is equal to I plus 3 in here as well. And then I get even fewer iterations because I is going up even faster. Generally, you want to modify your I or your loop index here in a for loop, but if your logic requires it, you can modify it inside of your loop. You don't have to start at 0. You can start at whatever value you want, and you can increment by whatever value you want, and it'll still operate under the rules of start at this value, continue while this is true, increment by this value. So I can also do, for example, downward, greater than 0, and then I can do I minus 1. So while I is greater than 0, start at 20, continue while I is greater than 0, and go down by 1 each time. So you can see that the for loop has a lot of control over how you want it to execute. Okay, next up is our while loop. The while loop, remember, is a loop that tests the condition before it executes. And since that condition is at the top, it can potentially execute 0 times. So let's go try that. Okay, let's create a variable called age. We'll say that this is start off at age 5, and while age is less than 18, what do I want to do? I want to do whatever's in this statement. So I'm going to do my console.writeline, and I'll write you at age you are in school. I'm going to use a interpolated string in C#6 so that I can use this placeholder with the name of the variable. I'll show you a little the original method of doing that. We would have written this as console.writeLine, and I would have written this out as at age and then placeholder number 0. You are in school. And then I would have made a list of the variables that are going to go in those placeholders. So placeholder number, the very first placeholder is placeholder 0, and I want the variable age to go in there. These both mean exactly the same thing. This newer scheme allows you to understand that the age variable is going right here in this statement. Either one will work. You'll see this older method all over the place in example code because until the recent 2015 release of C#, you couldn't use these interpolated string formats. And then this loop, since age is currently 5, this loop would run forever because age is always going to be less than 18. So I don't have a built-in modification. So I am going to modify this to say age is equal to age plus 1. And then I could do maybe a console write line out here. Congratulations, you graduated. See what this looks like. So you'll see that my age went up by 1. This looks very similar to a for loop, just because of the example that I was using. Generally, you would use these types of things when you don't have a pre-existing idea of how many times it's going to run. So a lot of times you'll use user input inside of here to end your loop. If, for example, age started off as 20, this would execute 0 times. The code inside my loop didn't execute at all, just the code outside my loop. And that's an example of the while loop testing for the condition at the beginning. Okay, very similar to the while loop is the do loop or the do while loop. And here the condition is tested at the end, which means that the code inside of your loop is going to be run at least once. So I'm going to change this around a little bit, and I'll do a console.writeLine or write, and I'm going to prompt the user to ask them enter your age. Now I'm going to get that age. Age is going to equal, I'm going to make the assumption they're going to type an integer. Not really a good assumption. I should handle that with error checking type code, but in these examples, I don't want to get distracted by that. The age is now in here, and if I do this, gotta get rid of that, and I gotta put my while condition at the end. While age is less than 18. Okay, so here's my do loop. It is going to execute at least once. That means this could behave in a way we don't expect it to. If I run this, I'm going to enter my age. I'm going to say I enter 6. I'm 6 years old. At age 6, you're a child, and it loops through until it gets to the end, and then congratulations, I'm an adult. The problem with this code is if I now run this again, and I put in 23, it starts off by saying at age 23, you're a child, and then says, congratulations, you're an adult. Well, now we know at 23, you're not a child anymore. And that's what is showing that the do loop executes the code inside here at least once. So this would not be a good example of the use of the do loop. This would be an example of a case where we should be using the while loop to terminate before we even loop. So there's the difference between the while and the do loop. And the last type is called the foreach loop. And foreach loops require that you have an iterable list. So any object that is iterable, and that means that there's already some built-in functionality of knowing how to work through the list. And in the base classes that we've talked about already, the thing that is iterable is an array. So we'll use that as our example. But it turns out that there's lots of things in the .NET framework that you can use with C# that are iterable. And so the for each system is actually kind of a quick way of building your loops. So here I have an example of iterating through a string list of strings. So we'll go ahead and show that example. So first I need to build my array of strings. Remember that an array is a type followed by square brackets, and then the name of the object. So in this case, it's going to be an array called myStrings. This is going to equal a new string array, and then I put in how many strings I want here. And what I'm going to use is I'm going to use this format that allows me to type in initial values here. And this will allow me to do like pre-fill my array for me. So what that will do is that will create an array called myStrings, and it will make it have these 3 strings in it. So now let's use the for each loop to iterate through there. So for each, and what is it that these things are? Each thing in this list is a string. So for each string, and I'm going to call that string something temporary. Like for each string s in, and in what list am I looking for strings? I'm looking for strings in the array called myStrings. So what's going to happen there is it's going to come into this loop, and it's going to say, okay, let's set s equal to the first string in this array. So s the very first time through, which should equal able, and then do some stuff, and then it's going to come back and it's going to basically behind the scenes look to see if there are more strings in the list, and if there are, it's going to set s equal to the next string in the list, which would be Baker. So inside my loop here, s is always the current string being processed. It's the current item from the list. So I could do something like console.writeline s. If we execute that, there they are, Able, Baker, Charlie. Now you may wonder why do I do it this way with this for each scheme? Couldn't I have done the exact same thing with a for loop? I could have. For int I equal to 0, I less than my strings dot count I plus plus. Remember, whoops, can't use that. My strings. Remember that in an array, I can access a particular element in the array with the index counter I, and so I'm gonna comment out this version. Okay, so let's see how that runs, and there's the exact same results using a for loop instead of a for each loop. You may wonder which is better. That's kind of a little bit of your personal taste, and but when you start dealing with systems that are objects, I kind of find that the for each item structure works because then I know that I have a temporary copy of my item already in my hand here. I don't know. It's just personal taste. A for loop will certainly get the job done, has for years. So those are my for loop types. What else do we need to talk about? Well, we need to talk about the break statement. Break is a way to get out of a loop. So if you've told a for loop that you need to run a million times and halfway through there you are done with the processing, there's no reason to run the other 500,000 iterations, so you might as well leave the loop. And the command that will allow you to do that is break. So here I have an example of break being used inside the loop. Uh, Normally, break would follow some sort of condition, like a test, like, oh, nothing has swapped, therefore we're going to break, something like that. But here in this case, if I started this for loop from 0 to 29, basically, it would write out 0, and then it would hit a break statement, which tells it to leave the loop. So it would jump out of the loop and end up on this code. So this for loop would only execute one time. Let's go look at an example of using a break statement. And I'm going to throw in an if statement here. If I is equal to 1, then I want to break. See what happens. You'll see Abel Baker printed, but Charlie never printed because when I got to the break statement, it left the loop. Another way of seeing that is for us to demonstrate the debugging capabilities of this software. In Visual Studio, you can actually move through your program line by line in a interactive debugging mode. Super powerful for finding problems and for watching how your program's operating. So over here on the left-hand side, you'll see that there's this gray bar. I can put in what are called stops. So if I hit the play button or the start button, my code will begin running up to that point, and then I'll be brought back into the debugger or the source code. So it's now sitting there waiting for this line of code to execute. And up here on the toolbar are some buttons that allow you to do various things. I can uh, I can move to the next statement. I can and I'm going to use either F10 or F11. For now, we're just going to use F10. So I'm going to step to the next statement. So I've now created my strings. And you'll notice that down here at the bottom of the window, we're beginning to see that I have a variable called myStrings that's now created. And you'll see that it has a string count of 3. This is called a watch window or a locals window, which allows me to watch the values of variables while my program is running. In terms of diagnosing and figuring out how your code is actually functioning, this method of stepping through line by line is super powerful. So here I am, and you'll notice that right now it's sitting at this line of code here where it's going to create this integer. So I'm going to step, and now it checks. It's checking to see if I is less than mystrings.count. Since mystrings.count is 3, the I is less than that, so it should execute. So it comes down and it begins executing. Here's my first line of code. It writes out to the console the value, and now it's going to check. Is I currently equal to 1? Nope. And so it loops back to the increment statement. It increments I by 1, so I is now equal to 2. Or I'm sorry, I is now equal to 1. And now it checks. Is I still less than the count of the list? Yes. So it's going to execute the code inside again. It writes out the next string, and then it checks. Is I currently equal to 1? And it is. So it executes this break statement, and you'll notice that leaves the loop. We're done with the loop, and it jumps out to my final line. And if I look over here at my code, there's my Abel Baker, and it does what we expect it to do. So using that debugging mode with a stop and stepping through your code is a really great way to see how the computer is executing what you've told it to do. You can have multiple stops in your program. You could have a stop there. I could have a stop here every time I come through the loop, in which case what I could do is I could get here. I can then hit the continue button, and it will run until it gets to that location. If I hit a continue, it'll run until it gets to that location. If I hit a continue, it would end the program in our case. So you can have multiple stops, and you can step through, or you can continue to the next stop. Both of those things are really good at debugging and figuring out how your program is functional. So that's break. Break leaves things early. Don't overuse it. Some programmers will use it as the default way of getting out of loops. You could just really kind of make loops infinite and then break whenever you need them to. That's, in my opinion, sort of lazy programming style. You should design your loops and structures in such ways that they have some semantic meaning to them, and use breaks when you absolutely need to. So that's it for looping. You should be able to loop things now. And coming up next is part 5 of the series called functions.